Alright, welcome. I wanted to make a video doing a problem similar to one in the book about using induction to prove divisibility results. So this is a problem, I think it's 1.7 in the book, and the problem says to show that 7 to the n minus 6n minus 1 is divisible by 36. And when does it want to be divisible by 36? Well, it wants us to show that for all, forgot to write this in, for all positive integers n. So we want to show that no matter what number n we choose, if we compute 7 to the n minus 6n minus 1, it's going to be divisible by 36. Now, it's really important to be clear about what the statements are that we're going to be using induction. So like we did in class, we have a P1, a P2, and I've just written some others down here. And so sometimes it's kind of simplest to kind of read off the nth statement, so maybe we'll do that here. So Pn says that if I do 7 to the n minus 6n minus 1, that is divisible by 36. So a common mistake would be to just think that it was just this first part, right? The statement Pn is a full mathematical sentence that says that expression is divisible by 36. And so now we can go through some other ones. So P1 would say that 7 to the 1 minus 6 times 1 minus 1 is divisible by 36. P2 would say that 7 squared minus 6 times 2 minus 1 is divisible by 36. P7 says that 7 to the 7 minus 6 times 7 minus 1 is divisible by 36. And finally, Pn plus 1 is going to say if we make that exponent n plus 1, and we put n plus 1 in for n, that whole expression is going to be divisible by 36. And now remember our strategy in induction is going to be that we're going to prove that P1 is true. We'll do that as a separate case. Right now we can look at it and see that, well, this expression 7 minus 6 minus 1, that's going to be 0, and 0 is definitely divisible by 36. And it's 36 times 0. And our other strategy is going to be to show that if Pn is true, then Pn plus 1 is true. So we're going to say if we've proven the statement in row n, then automatically we're going to get the statement in row n plus 1. So let's see how that goes. So I've set up kind of our basic induction outline. If you notice, this you could even write this for every induction problem because they're all going to go kind of the same way. Our first step is to show that P1 is true. And so let's go back and see what P1 is. In fact, I'm literally gonna copy it from here. So I'll copy and paste. Right? Obviously, you won't copy and paste unless you have scissors, but let's go ahead and simplify this. So 7 to the 1 minus 6, that's going to be, because this is equal to 0, it's equal to 0, which is divisible by 6. And in fact, let me just clean this up just a little bit. Probably the way you would write it, you wouldn't copy paste, as you would sort of say that you would work out P1, you would work out that number 7 to the 1 minus 6 minus 1, you would see that it's 0, and you would say that it's divisible by 6, and then you would conclude therefore that P1 is true. Okay. Usually there's not so much work involved with step P1. Now let's move on to our next step. So that we need to show that if Pn is true, then Pn plus 1 is true. So we're trying to show that if we assume that Pn is true, so let's do that. So let's assume, so we assume that what was Pn? We assume that 7 to the n minus 6n minus 1 is divisible by 36. Okay. And so let's rewrite that. In these divisibility proofs, sometimes we have to rewrite that as an equation. So, i.e., 7 to the n minus 6n minus 1 is equal to 36 times k for some number k, let's say some integer k. Right, that's what it means to be divisible by 36. It means that it's 36 times an integer. And then that's going to be our assumption. Right? And now what do we want to show? Well, we want to show that 7 to the n plus 1 minus 6 times n plus 1 minus 1 is a multiple of 36. And again, I want you to sort of think about this. Remember that we're sort of assuming that if we make the number n, then it's a multiple of 36. And what we want to show is that if we make the number n plus 1, that we can deduce or conclude that that must also be a multiple of 36. Okay? And so now the only thing we can do is we can sort of say, well, I've got this equation here, 7n minus 6n minus 1, and maybe I can kind of work that into my expression there. So let's see if I can simplify, right? Well, I look at 7 to the n plus 1. Well, that's going to be just 7 times 7 to the n. Right, so if I do some simplification, I see that's going to be 7 times 7 to the n plus 1. Sorry, 7 times 7 to the n minus 6n minus 6 minus 1. If I simplify, I'm going to get 7 times 7n minus 6n minus 7. Okay. And if I look at that, I say, oh, well, maybe I can substitute in. Maybe I can substitute in this expression. Right? Let me do it with a different color. I see that 7 to the n is appearing in both of these expressions. Okay? And so I can now add, I can sort of say by the induction hypothesis, I know that 7 to the n is equal to 36k plus 6n plus 1. Right? I've just kind of solved up there. And so therefore, I can simplify my expression 7 to the n minus 6 times n plus 1 minus 1. That's going to be, I've got this expression over here is 7 times 7 to the n minus 6n minus 7. And now I'm ready to substitute in. So it's going to be 7 times 36k plus 6n plus 1 minus 6n minus 7. And I guess we're not quite ready for our conclusion, so we'll kind of delay that a little bit. Let me just cut that out of the way and do a little bit more algebra. Again, this is maybe something you can do on your own as I'm talking through this on the video. So we get 7 times 36 plus 42n plus 7 minus 6n minus 7. When we simplify, we get 7 times 36 plus 36n plus 0. Remember, those 7's cancel. And remember, what were we trying to show? Well, our goal was to show that this expression that we've just simplified is supposed to be a multiple of 36. And now we've looked at this. This is that 7 to the n plus 1 minus blah, blah, blah. We look at it and we say, can we deduce, can we reason that this is going to be a multiple of 36? And I think we can, right? I think it's literally 36 times 7k plus n. So, which is a multiple of 36. And so now we can conclude that statement Pn is true. Right, so therefore, statement Pn statement P n plus 1 is true. In fact, let me just copy or paste back in our statement. So we've completed that induction by assuming that statement n was true, and we're sort of shown that statement n plus 1 is true. So you will have a problem like this on the homework, one of these divisibility results. And so there's one worked out in the book. I've got this video to help using a combination of the two ideas. I hope that helps. And of course, if you have any questions, feel free to let me know. See you soon. Bye.